If it is, here we go, right? So there's different types of polynomials. I don't know that this vocabulary is necessarily on the assignment. I just may use it from time to time, but for the most part, polynomial and monomial is kind of what I like to stick to.
How about this binomial?
No, the binomial is as well. So we'll say binomial. This tells you how good Mr. Sal is at typing and how good spell check is some days as well, because I do use it. Anyways, binomial, bi is 2, monomial 1, tri is 3. Technically, binomials and trinomials can fit into polynomials. Poly is many, which to me I would think is 2 or more. But I guess specifically we may say polynomial or refer to it when it's just 4 or more terms. So there's no such thing as far as I know, although there could be, as a quadrinomial. It just sounds laborious.
That would be tetranomial.
I'm definitely not going to go in that direction, though. So here we go. So there's going to be a problem that has this vocabulary on it, okay? Some of it I use the word coefficient quite often, terms as well, which we've talked about, and then, of course, polynomial. But the degree of the polynomial is the sum of the exponents of the variables in the terms, just the variables. So if a number in a term has exponents, I don't care about that stuff because it can be evaluated. It's the exponents of the variables. Now, usually for us, we should only see one variable at a time. But we know it's possible, or perhaps we know, that it is possible to see something like xy squared. See, so the degree of this, if this was a term, would be 3. 1 for the x, 2 for the y, total of 3. Now that's not an exponent rule. That's a polynomial thing, finding the degree of the term. On the other hand, let's say that we just had another term like z. If it was z, let's say the power of 8, then the degree of this individual term is now 8. But what if it was like 4z to the power of 8? It's still a degree of 8. The 4 has nothing to do with the degree. Good. All right, degree of a polynomial is just the largest degree of any of the terms. You can find the degrees of every term. It's the degree of the highest term, the highest degree of all the terms. And then, of course, a coefficient is a number just being multiplied by any variable. It could be an x, it could be a y, it could be a z, an m, an n, an a, a b. It doesn't matter. Coefficients can just be anything multiplied, any number being multiplied by a variable. And then the leading term, I had to change this, so if you printed it out, the leading term is the highest degree term. So the leading term and the degree of the term the degree of the polynomial and the leading term kind of go together. Same with the leading coefficient. It's just the coefficient of the leading term. Now, I'm going to emphasize this once again. If you saw that you had a term, whether it's leading or not, like x, right here, you need to remember that it has a coefficient of a phantom 1. So I'm showing the 1, so it's not necessarily phantom anymore, but sometimes you may not see it, okay? Then it's a phantom 1. But it's still there, lurking in the shadows, always watching, which is why those leading or phantom 1 coefficients are kind of creepy. So addition and subtraction determine if a term is positive or negative. So let's say, for example, up here at the top, y squared minus 4z to the power of 8. For some reason that 8 looks kind of like a b, but this minus sign right here would make this 4z to the power of 8 term a negative term because of the minus sign. I really do hope that all of that stuff is not new for us, but if it is, so be it. Okay, so first term, second term, third term, fourth term, fifth term, right? And we can kind of order these up here. This is first term, second term, third term, fourth term, fifth term. In math, sometimes they may ask for something like, they may say, put it in descending order. So that's from greatest to least. This one is not in descending order, and we don't care. It's just, they're numbered usually from left to right, though. So the first term here is x to the power of 4. What is its degree? Well, the exponent of the x is 4. Its coefficient is a phantom 1. Oh, that was nice. Well, what about the next term? It's a negative 5. The degree, since it doesn't have an x, we would say it has a degree of 0, which is also kind of like x to the power of 0, which is 1. It's kind of like a phantom 1, just with a base x. No, it would not be a degree of 1 because the x would technically have to have a power of 0 to make it the full value of it a 1. Yeah. And then the coefficient, of course, here we would just say is -5. The third term, -8x to the power of 2. Its degree, again, I don't care about the -8, but the power of x there is 2, so it's a degree of 2 with a coefficient of -8. Then the fourth term, 6x to the power of 3. Again, the 6 I don't care about, but the power of 3 of the power of x, which is 3, is the degree, and then the coefficient is 6. And then our fifth term is just 6x. So this is another case where it's not showing the exponent, but it's there. It's a exponent of 1, degree 1, and the coefficient is 6 again. So then last of all here, it says, what is the leading coefficient? So the leading coefficient is, we got to find the highest degree term, which is up here at the top, right? Yeah. So I'm going to box it in first, though. So it has the leading coefficient. Its coefficient was 1, right? What is the degree was 4. That's the highest degree. And you can just compare all these degrees that we have there. And so what is the degree of the polynomial? It's always going to match the degree of the leading term, the highest degree. Now, since this lesson's about addition and subtraction of polynomials, this one has five terms. So it's just classified as a polynomial, but one thing I would hope you'd notice on this is that, because I would check, is you want to notice if there's any like terms that you can combine. So just having an x doesn't make it a like term, which is also why we need to distinguish between the degrees. There are x's, but they're not like x terms because the exponents do differ. But today, part of today's lesson is knowing how to combine these, even when the bases may be the same like this or different, and then the exponents may be the same or different as well.